Okay, so we have an example here where we're given a table of information and we want to match which graph matches the information. And so on number 13, we're given that with x equals a, that this derivative doesn't exist. So if a derivative doesn't exist, then I know that there's some sharp corner that's happening at that value x equals a, or it's a jump in the graph, or it's undefined at x equals a. So I would look at my graphs and see, is there any place when x is a where it would have a sharp corner? And so in this case with the graph x equals or graph of a, there is a sharp corner here. So this could be a possibility, but I would go and make sure there was no other possibility. X equals a here, this is a smooth and it's continuous right there around that x equals a, so that my derivative does exist and it would equal 0. So this one that doesn't hold, that x equals a doesn't exist. Same idea with my graph C. This is smooth and it's continuous around x equals a. And so my derivative at x equals a would actually be 0. And so this would be an example where that graph wouldn't work. This one though, we have a sharp corner. So at D, this derivative f prime of a doesn't exist. So I know that I have two possibilities and then I would just go down and continue. So now I'm looking at when x is b. So when x is b, I know my first derivative, I get 0. So I know I'm going to have that tangent line is leveling out. Well, x equals b here, f prime of b actually doesn't exist because it's a sharp corner again. So this graph of a can't hold. And so I would look at this next one, D. Here at x equals b, that tangent line, that derivative at b is 0. Okay, so this value here, this holds for graph D. I will just make sure that the last condition held. And so when x is c, it says my derivative is -2. So that tells me that my graph at x equals -2, my slope is negative. My slope is negative, then I know that my graph is decreasing there. So let's look at when x is c. Look at our graph, it's decreasing at that value. And the slope is -2 there. And so that also holds true. And so my graph for number 13, it's going to be graph D. So I would do the same thing for number 14 to find that graph. I see that A and B, the derivative doesn't exist, so I'd have to have a sharp corner at x equals A and at x equals B. And that at C, my first derivative is -1.7, so it must be decreasing. And I would make sure that the graph I chose, all three of those conditions held true.